Hello, good morning. In this lecture video, I will cover chapter 4 and chapter 5 that includes Newton's second law and Newton's first law of motion. Okay, so in chapter 2, you study about the first law, that is the law of inertia, right? What is inertia? You already know it. So let me explain Newton's first law first. Uh, It is law of inertia. In nature, every object in nature remains in its state. That means if they are at rest, they remain at rest. If they are in motion, they will continue their motion in a straight line in one direction. If you don't apply any force upon it, if there is no net force, right? That is definition of Newton's first law, or we call law of inertia. Okay, so now let us discuss Newton's second law. Look at some uh, uh, activities. So if you look at around you, if you applied force on an object, for example, here you can see figure. This is a ball. This little girl is applying certain force on this ball and it is moving, right? That means accelerating. If acceleration means if velocity is increasing, then that is acceleration. If you are driving, if your velocity is constant, suppose you are driving in interstate and your uh, speedometer shows 60 miles always, that means your velocity is constant. Okay, that is no acceleration. So, but if it is increasing, then suppose speedometer is showing like 50 kilometer per hour. After certain time, if it is like 55 kilometer per hour, and then another minute, it may be like 60 hour 60 kilometer per hour or 60 mile per hour. That means velocity is increasing and that is accelerating. That is said to be acceleration. So what we understand from these examples is if you applied force, to increase the velocity of your car, you have to push on accelerator, right? That's why it accelerates. The name comes from the acceleration. When you push on the gas, that is the force because of combustion of gas. It comes from the combustion of gas. So applied forces causes acceleration, move more faster. We can say like this. Look at here until uh, we don't apply force, this ball remains at rest. That is the first law. When you apply force, it will move, right? It will accelerate. So acceleration is consequence of application of force on an object. Okay, look at here. Acceleration depends on net force, right? If net force is more, acceleration will be more. If net force is less, acceleration will be less. This kinds of relationship between any two physical quantity is said to be directly proportional relationship. That means if you increase one, another one will increase. If you decrease one, another one will also decrease. That is, same proportion. That's why the directly proportional relationship. If you look at, physics, it is interesting. Look at here, it will happening always around you. So it is not difficult. You just have to observe the phenomena and explain in right way. That is the only thing you have to do. Okay, look at here. From observation, what you get it. If you suppose double the force, what happened to acceleration? Does it double or it becomes a half than the previous one, or it becomes a four times what we have before? You can observe. By observation, what we will see, what we will observe is if you double the net force, the acceleration will double. If you triple the force, acceleration will triple. If you increase the force 4 times than before, acceleration will be 4 times, right? It means acceleration is directly proportional to the net force acting on it. So acceleration is proportional to, this is the proportionality sign right here, to the net force. Okay. Okay. What about mass? So when you increase force, one physical quantity is acceleration and it increases, right? So what happened to the mass? Every object has mass. Suppose this ball has mass, maybe 50 gram or 100 gram, right? So if you increase mass, if mass, this ball has 100 kilogram mass, now 100 gram mass, you kick it, and there is another ball having 200 kilogram mass, and you kick it with same force. What will happen? Which one will have more acceleration? That is the question. Okay, look at here. Observation 2. Acceleration imparted on a body also depends on the inertia of an object. Okay, how much inertia an object has depends on amount of mass. That is mass dependence of acceleration. So in this case, what will happen is, this is a normal experience, daily life experience. If you have to apply a force, you have a box in your room, you are lifting a box, suppose it is 50 kg, you can lift it. If you double the mass, for example, it is 100 kilogram, can you lift it? Not at all. 100 kilogram is too heavy to lift, right? It means if you increase the mass, the acceleration will be decreased. The movement means acceleration, right? If you increase the mass, acceleration will be decreased. So if you decrease the mass, acceleration will be increased. This kinds of relationship is called inversely proportional relationship. The previous one is directly proportional, and this one is inversely proportional relationship, right? Inversely means if one thing increase, other thing decrease. If one thing decrease, other thing increase. That's just opposite, right? So mass is a quantity of matter in an object. You may be familiar with this definition. And mass resists acceleration. That means acceleration will be decreased if you increase mass, and the acceleration will be decreased when you increase mass, and decreased when increase mass. That's just opposite. Okay, so from these two observations, we see the relationship of acceleration with net force and mass, right? With net force, acceleration is directly proportional. That's why it is on numerator, right? If you increase net force, acceleration will be increased. If you decrease net force, acceleration will be decreased. Mass on the denominator, because if you put a mathematical, the numerical number, you will get it. If you increase this one, this value will be decreased. If you decrease this one, this value will be increased, right? So this one gives us the relationship between acceleration among acceleration, net force, and mass, right? So in symbol, how can we write it down? A equal to F by M, right? So A means acceleration, it is a small letter. Remember these kinds of symbols. And F is net force, and small m is mass, okay? F is capital here, m is small, and A is small letter. Remember these symbols also. So from this one, what we get is F equal to m A, right? F equal to, what happened to this? Okay, yeah, F equal to ma. This is Newton's second law of motion. Force equal to mass multiplied by acceleration. Look at here. If you have mass of an object and acceleration, then you can easily find out force. How much force is applied there, right? And if other two quantities are given, you can calculate the one. Like if you have mass and force, you can calculate A. If you have F and A, you can calculate M. Okay. So let us discuss more about force. Friction is a kind of force. What is friction? When two objects slide with each other. I have a cell phone, and if I'm trying to slide something over here, there is always force acting opposite to this motion. The subject is sliding down, and some force will always oppose the direction of motion. Suppose this is moving in this direction, the force will apply to opposite direction. That is frictional force. So frictional force will always be opposite to the uh, direction of motion of an object. That is the friction. Okay. When you roll something or slide something on the surface, it is difficult to slide. You can feel it, right? Friction is caused by the irregularities of the surfaces with mutual contact. That is the cause of friction. Normally, the surfaces that you have seen, like a smooth one, if you see microscopically, there is like a hills, small hills and groves, right? So when you put this one object into the top of another, what will happen? There will be lock, right? Lock like this. This is the magnified image of this surface, the interface, this object and this object interface here, right here, right? So look at here, there are small hills and the valley is like this. And what is happening? This portion is interlocked here, this portion is interlocked here, and so on, right? That is the cause of friction. So the direction of friction is, remember, always opposite to the direction of motion. If this object is going this direction, friction will be opposite direction. If this object is going this direction, it will come back. The friction will be opposite direction, means this direction. Okay. I mean, suppose this is the direction of motion of an object, and then friction will be just opposite, right? Remember this thing. This is very, very important to remember. Okay. So another thing you have to notice here is friction does not depends on the area of contracts. It depends on nature of the surface. If roughness is more, frictional force will be more. If roughness is less, the frictional force will be less. Okay. Why we make tires like this? Why not like a box? Why not like a rectangle or a square or triangle? The tires of car has this kinds of shape, which are round, right? They rolls on the surface of road, right? So why we made like this? It is because when things rolls over another thing, another objects, the frictional force acting towards opposite direction of motion is less than the sliding friction. If you make something like, the tires like this shape, what will happen? They cannot roll, They should slide over road, and what happens? There will be more friction, and within 10 mile or 20 mile, if you have to replace your tire. Is that good for you? Of course not, right? So the tire should be durable. So less the friction, the tire will be more durable, right? But at the same time, there should be certain friction also. If there is no friction at all with your tire and a surface of road, what will happen? There will slip, right? The result is accident. So the friction is, that's why friction is said to be necessary evil. It is a evil, right? Because it is stopping our motion, but it is necessary. If there is no friction at all, you cannot move. Okay, so friction, we can categorize friction in two kinds. One is static friction and another is sliding friction, right? So static means when this person is pulling this box and it is not moved yet. That is static friction. There is a frictional force. This guy is pulling this box this direction, and the friction is pushing opposite direction of his pull, right? So the friction until when the object does not move, however, the person or force is there, right? Force is there. Certain force is applied. The friction is acting opposite direction to the applied force, but if this object is not in motion, then we said static friction. If it is in motion, then it is said to be sliding friction. Okay, so always, static friction is more than sliding friction. That's why you can do experiment at home. When you try to pull any objects first, it will be very hard. You have to put more force. Once it gets slide, what happens? It will be much easier to pull this object, this box, right? If you don't feel it, or if you don't notice this kinds of thing, you can do it. It is easy because physics is around you. Friction is not restricted to solids. It will act on water, it will act on gases. You know, the airplane and shape of pieces like that. Why? It is the engineers does not design airplanes like a bus, like rectangle. Why? Because if they make the airplanes like bus, there will be more air friction. In general, if our velocity is less, our acceleration is less, we can't feel air friction that much. But airplane, the velocity is 600 miles, probably 800 miles, faster planes, right? 1000 miles per hour. It is too much, and air resistance is also too much in the air uh, airplane, right? That will may cause fire. Excess friction may cause fire. That's why to reduce the air friction, they make the shape of the airplane such that air friction could be reduced. It's pointed, and air coming to contact with airplane will slide over or below the airplane, right? That's the design. So naturally, the shape of fish is like a fish that reduces water friction or liquid friction, right? So that is the key. Look at here. When they move faster in water or in air, they feel friction. Now, what is weight? What is weight? Right? Generally, that we said in normal life, weight is not a weight. That is the mass, right? Weight is the push because of the gravity. It changes with place to place. Your weight at the bottom of a hill is more than at the top of the hill. Or your weight right here on the surface of Earth is different than your weight on the surface of Moon because the weight depends on the gravitational pull upon that object. If you go to Moon, you feel lighter yourself. Your weight will be less. Okay, how can we calculate weight? You can simply calculate weight by using this formula. W is weight. W is equal to mass multiplied by Z. What is this Z? This is acceleration because of gravity. Acceleration due to gravity. If here on Earth, value of Z is 9.8 meter per second squared, right? Meter per second squared. So of course, the unit of weight are Newton. Unit of mass kilogram you already know. And the unit of acceleration is right here, meter per second squared. So weight is measured in Newton. In Newton, there is kg meter per second squared. So in Newton, there is a kg and here meter and per second squared, right? So this is the unit. Okay, let's move. So calculate weight, that is F equal to ma, okay, or we can say mg. So if it is weight, we can say that is a force, but we can say w, right? That is the weight. So F equal to mg or weight equal to m into g. If your mass is like 60 kilogram, SI unit is kilogram, not a pound. That's why you can use SI unit for uh, mass, right? G is acceleration. You also have to use like a SI system in a SI system. Okay. Let's go. Example, calculate the weight of a boy whose mass is 50. Let me calculate it for you. Okay, so that it will be easier for you for other calculations. I know formula of calculating weight, which is mg. Mass of a boy is given. That's why I can write down 50. And I know value of z is 9.8. I have a calculator here. If I multiply 9.8 by 50, I will get 490. Okay, so which is 490 Newton, right? So this is weight of a body. Okay. So in normal life or daily life, what you say weight is not weight; it is mass. Okay, mass never changes. Mass remains constant. Anyway, we have done this part, and let me go ahead. Yeah, here is acceleration due to gravity is given. I'm skipping this part. Okay. Okay, free fall. What is free fall? If acceleration is equivalent to 9.8 meter per second squared, that is acceleration due to gravity. So person feels like weightlessness. So that is said to be free fall. The Newton's second law provides an explanation for the equal acceleration of freely falling objects of various masses. Acceleration is equal when air resistance is negligible, right? If there is no air resistance, then acceleration will be 9.8. So in that case, that is the free fall. Acceleration depends on force and inertia. We already discussed about those things. Okay. So there are few activities. Calculate the weight in Newton of a person with a mass of 130 pounds. So let me calculate the weight. There is just you have to convert 130 pound to kilogram, right? Simply conversion factor is given here, just multiplied by 0.45, right? Let me multiply it and get it for you. 130. Sorry, what is happening? 130 into 0.45. Okay, 58.5 kilogram. It is 58.5 kg. I get in kilogram, right? Now, what is the formula for weight? Weight is equal to m into z, right? So 58.5. That is the mistake. Okay. Into 9.8. So let me calculate this one. 9.8, I'm getting 573.3. 573.3 unit of weight is Newton. Don't forget to write down Newton. Okay. So this is solution for this question. Okay. So let me move to the another question. If you have, I will leave for you. You can do it. Calculate the weight of 2000 kg elephant, right? Just multiplied by 9.8. It will give you 9098 after 2 zeros, right? 98 multiplied by 2, it will be something different. It's about like, 20,000 or near to 20,000. Just multiplied by 9.8. That's all we'll get weight. I'm not doing this. An apple weight about 1 Newton. Weight is given here. Now, what is its mass in kilogram? It's easy, right? Look at here. Simply, yeah, W is given 1 Newton. So, 1 Newton equal to mass divided by 9.8, right? So, mass is equal to, let's say in 1 divided by 9.8 kg. This is the mass. What is 1 divided by 9.8 is 0.102, right? 0.102. This is kilogram, right? So if you say in gram, it is 102 gram. It is reasonable, right? Apple had this much gram, 100 gram about. So this is the weight of. These are not difficult problems. Probably you can do it. And so she finds that she's weight, her weight is this much. Right here also weight is given. What is her mass in a kilogram? What is her mass in pounds? So you can convert into pounds. Conversion factor is given here at the top equation, right? You can do the rest of the questions. If you have any problem, you can ask me anytime. In previous sections also, homework. Also, if you have problem, you stuck somewhere, don't hesitate to ask me by email, or if you ask me question, then I will post videos explaining how to deal with the problem. Okay, so I'm here to help you. Don't hesitate to ask me. I like the questions. Okay, so Newton's third law of motion. According to Newton's third law of motion, there are forces in pairs, right? There are forces in pairs. If they are not acting with each other, there is no existence at all. When you kick the ball, You apply the force on ball, and the ball is also applying force towards you. These two forces will be equal and opposite to each other. If you put some objects in the table, that object will act certain force on the table, and the table also exerts certain force on the object. That is the pair of forces, and always these pair of forces are equal and opposite to each other. Okay, that's the key. Interactions. Interaction happens between one thing and another thing. We need two things to have interaction, right? This is one thing, there is no interaction. This is two things, there is interaction, right? So if I'm pushing by this hand to this hand, then this hand you can say action, and opposite hand is also pushing. That is reaction. So action and reactions are always equal and opposite to each other. So interaction of hands and wall. Suppose that this boy is pushing wall. Pushing wall by this hands, this little hand is action. And wall is pushing at the same time opposite to this boy's force, right? That is the reaction. So this makes a pair of force. Okay, right here, look at here. So here is the Newton's second law of motion. Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. This is the statement. Okay, look at the figure here. What is happening? This car, these two trucks are small car and big trucks are colliding each other, right? This is action, this is reaction. Action and reaction. These are pair of forces. So there will not be existence without the one. If two cars are not colliding, there is not force, right? They will be equal in strength and opposite in direction. Always acts on different objects, not in the same object. It could not be possible, right? These are some important points you should remember. If you have any question, you could ask anytime again, okay? Action and reaction on different masses. Look at here. What is happening here? This is cannonball. Boom. This is cannon. The force acted by this cannon on cannonball is action, right? The force acting by cannonball in cannon is reaction. But if there is a question, why when these two things, that is ball, cannonball and the cannon, exerts equal and opposite force, so why not both have same acceleration? Look at here. Answer is given here. This is for cannonball. Look at here. Mass of cannonball is small, so you will get the huge acceleration. That's why this is huge. And what about the cannon? This cannon mass is too much. So if you divide, force is same. If you divide by huge number by small number, then what will happen? This number will be small, right? Acceleration will be smaller for this one. So this is not accelerating that much in comparison to cannonball. That's why we see cannonball is moving rapidly. Acceleration is too much, but this cannon is not going back as comparison to this cannonball. So this is because of ball, but force is acting opposite with same magnitude. Okay, a force exerted on a small mass produces a large acceleration. One, the same force exerted on a large mass produces a small acceleration. That's what we get from Newton's second law, right? If mass is more, then acceleration will be less. If mass is less, acceleration will be more. That's the second law. That's why it happened in cannon. Wow. Look at here. Both are moving, right? But we can't see the movements of this cannon. Why? Because it has mass, big mass, and we cannot notice in comparison to this one. This is going super fast, but cannon is not going that much fast, right? When a cannon is fired, the acceleration of the cannon and the cannonball are different because the mass are different. Masses are. Consider a high-speed bus colliding head-on with an innocent bug while driving through the interstate or through the forest. There are many bugs colliding with your car, front shield of your car. The force of impact splatters the unfortunate bug over the windshield, right? Which is greater, the force on the bug or the force on the bus? Answer it first. Within a couple of seconds, I will answer you and explain. You may think a different answer. Probably you thought the force because of your car on a poor bug is huge force. Do you think like that? If you think like that, that is wrong. According to Newton's third law, both forces should be equal and opposite. That's why the force applied by that poor bug and our big car, huge car, is same. This is bug, a small bug, colliding with huge car. It will be force will be same, but mass of that poor bug is very small and it splatters, right? So the force is equal, not greater. Okay. So here is the summary of Newton's three laws. First law is law of inertia. It explains inertia. An object at rest tends to remain at rest always if external force is not applied, right? An object in motion tends to remain in motion at constant speed along a straight line. If path is changing, if path is circular, then there is a force, right? This is the Newton's first law. Until you don't apply external force, objects remain in its state, rest state or motion state in uniform motion in one direction. This is one thing. Newton's second law, force equal to ma, right? The acceleration is directly proportional to the force, net force, and inversely proportional to the mass. That is F equal to ma. And the third law is the law of action and reaction. Second law is said to be law of acceleration. First law, law of inertia. Third law, law of action and reaction. Whenever one object exerts force on a second object, the second object exerts an equal and opposite force to the first. These are three important laws of motion given by Newton. Okay. The boxer, what is there? Practice second law. A boxer punched a sheet of paper in mid-air and brings it from rest to a speed of 25 meters per second in 5 seconds, 0.05 seconds. Okay. What acceleration is imported on the paper? Okay, let me do for you this one, then it will be easier for you. It is asking acceleration. Velocity is given here, v divided by t. So velocity is this one, 25, and time is this one. Put this one. If you put these values, I am doing calculation like 25 divided by 0.05, and what is happening? Let me go to another calculator. That calculator is not good. Okay. Let's wait a minute. 25. It's 25? 25 divided by 0.05. Okay, 500. I am getting 500. Do your own calculation. 500 meter per second, right? Per second square. So that is the acceleration. if the mass of the paper is this one, what force does boxer exert? F equal to ma, right? Ma. So how you get these values? Mass is given here and the acceleration is given here, right? It's not difficult. How much force? Put values. It is 500. I already get it. 500 meter per second square. Okay. So how much force does put the value and get the answer? And it will not be wrong. Just do calculation. How much force does the paper exerts on the boxer? Use Newton's second law. Third law, it will be equal and opposite, right? Whatever you get here will be the same force exerted by that paper in the boxer's box punch, right? If any question, you can ask me anytime by email, and I will be glad to help you all the time. Okay, thank you.